Alright, let's get on to question 5. This is a rates of reaction question. Let's just read through the question before we start getting into the subsections. The reaction is between zinc powder and hydrochloric acid, so it's Zn plus HCl. Notice that the hydrochloric acid is cold, which indicates a low rate of reaction and possibly a question later on to do with an increasing temperature. The zinc powder, you'll notice in the setup, has been put into a small test tube, and the hydrochloric acid is in the flask. And the way they've got it set up, you can see that the zinc powder is not in contact with the acid yet. The reason for this is to allow the start of the reaction by just dropping the thread, allowing the two to react, so that the rubber bung's already in and we don't lose any gas. And then you've got the cotton thread holding the test tube up above the acid to keep the two reactants apart until the reaction starts. You'll notice that there's a gas syringe set up to collect the gas that results from the experiment. In this case, hopefully you can see that will be hydrogen gas. Okay, let's get on to 5.1. The question is asking for a balanced equation, including phase symbols. And you're told that the salt that's formed is zinc 2 chloride. So we have to start by finding the formula of zinc 2 chloride, so let's do that. Zinc has a bond number of 2. It's told in brackets after the zinc. That number, Roman numeral 2 there, indicates its bond number. Chlorine's bond number is 1 because it's in group 7. And so you cross those over and the formula of zinc 2 chloride is ZnCl2. So let's get on and write the balanced reaction then. We've got zinc, which is a solid, reacting with hydrochloric acid, which is HCl, which is aqueous, which means dissolved in water. And that forms the salt zinc chloride, also aqueous, and hydrogen, which is a gas. And then you need to balance it. The hydrogens aren't balanced. There's only 1 on the left and 2 on the right. The chlorine's unbalanced, again 1 on the left, 2 on the right. And so we just need a 2 in front of the HCl to give us our balanced equation. Right, 5.2, how do the students start the reaction? I explained that already. The key here is for you to simply indicate, according to the diagram, that to start the reaction you need to lower the cotton thread or break the thread or something to that effect, which then will allow the acid to react with the zinc. So your answer just needs to relate to the practical setup and indicate that that cotton needs to be either broken or lowered to allow the two to react. Alright, 5.3, I give you the data that's been collected from this experiment and ask you to plot a graph. Let's just have a look at our two variables. Time is our one variable. Notice that it runs from 0 through to 7. And our second variable is the volume of gas, the hydrogen that's released. And again, that's running from 0 through to 55. So we need to set up our graph with a time axis, and that's the independent axis on the x-axis of our graph, and the volume of gas, which will be our dependent variable, on the y-axis. So let's go. Sorry, the question then asks you to put in a best fit curve. There's our graph paper. So you would set up your axes and decide on your scale, so that we have our x-axis of time. Don't forget to put the units in brackets. It's given in the table as minutes. Y-axis is volume of gas. Again, units cm cubed. In this case, we have a real origin because both axes start at 0. So it's common then to put 0, 0 at the origin of both axes to indicate that. We then put in the numbers on our two axes, and then go ahead and give yourself a sensible heading. The best way to do this is to simply indicate what the dependent variable is against what the independent variable is, and then describe the reaction. So in this case, it's the volume of hydrogen released against time for a reaction between zinc and hydrochloric acid. And then plot the points, and do that carefully, taking account of the scale. And then draw in your best fit line, and they ask you to label that A. Right, 532 asks you to explain why the volume of gas remains the same for the last 2 minutes. So in minute 6 it's 55, in minute 7 it's also 55. And hopefully you understand that that means the reaction has finished. Be careful, this is not an equilibrium reaction, so it hasn't reached equilibrium. The reaction's finished and no more hydrogen's being produced. 55 cm cubed was produced and no more. And the reason that no more is produced is the second part that you need to understand, and that's because all the zinc has reacted, because in the original question it told you that HCl was in excess. So the zinc will be used up first, there'll be some HCl left over. Alright, 5.4. Here's the link with the original question that spoke about cold hydrochloric acid. 5.4 now indicates that the experiment's repeated using warm hydrochloric acid, and they ask you on the same graph to draw the curve that you would expect. So let's go back, and there's our original graph. There are always two things to consider in a question like this. Firstly, does the rate increase or not? And clearly with warm HCl, that's going to increase the rate of reaction, which means that the curve will be steeper initially. And you can see there the curve I've drawn in red. It has a steeper gradient, which indicates a greater rate of reaction. The second thing to consider is, where does the graph finish? Does it finish at 55, as the previous graph did, or would you form more hydrogen gas or less hydrogen gas? Now, by changing the temperature, you're not adding any more HCl or zinc in this case, because that's the limiting reagent, and so you would expect the same final amount of gas, and so the graph would finish at the same point. And that's graph B that was labeled. Alright, 5.4.2 asks you to explain the graph that you've just drawn, and so let's do that, a change in temperature and how that affects rate. And so the first point you need to make is that at a higher temperature, the particles all have got greater kinetic energy. And if the particles have greater kinetic energy, it means that the rate of successful collisions increases, and hence the rate of reaction also increases. And the word rate there is key. It's the number of successful collisions per unit time. That's another way of saying it. But you must have that word rate of successful collisions to explain why the temperature increases.